Okay, so we covered contrast tuning and contrast enhancement in the lecture. Now let's see what that really means in practice. So I'm looking at the semiconductor sample again, the device that we saw in some of the previous lessons. And I've gone into the EFTEM map technique. So let's just rewind a second. So analytical TEM and EFTEM map. So I'll start a live camera view and just increase the view time a little bit. So when we're doing contrast enhancement or contrast tuning in EFTEM, remember that we're just looking at single images. So all we need to do is insert the slit and then select some energy range. So right now we're looking at an unfiltered image. I'm going to insert the slit. Slit's really wide at the moment, so I'm going to drop the width down to 10. So this is our first example of contrast enhancement. So this, I'm doing zero loss filtering. So I'm enhancing elastic scattering contrast. So I'm enhancing diffraction contrast in the image that we're looking at. If I start to increment the energy loss, then you can kind of see that at some point that the contrast will just flip. So now I've offset the energy by 5 eV. We see that one of the slit edges is now in the field of view. So this pattern that we see is because the beam is focused, or the spectrum is focused on the edge of the slit. So that's normal. So if we go a little further, then we see this contrast kind of change. And it starts to look more like a dark field image. We have black in vacuum and kind of bright contrast in the sample. So I'm actually going to switch to the LD mode, but we're going to cover that in a later lesson. So let's use the LD mode and increase our view time a little bit. So this is kind of nice way of like kind of looking for kind of plasmon contrast or kind of low energy loss contrast. So I'm just going to increment the energy offset by kind of 1 eV steps each time. So right now we have kind of bright contrast here, 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 and in the kind of silicon. And as we keep going to higher energy, then you see the contrast changes. And that's really because we have different kind of low loss features in the sample. And it's kind of a neat way of contrast tuning. Actually, I have quite a wide slit at the moment, so it might be interesting if we drop the slit down to 5 eV. Let's increase the exposure time to say 0.5. And then let's go back again. So we've kind of got, so I can do a really coarse way of grabbing some images. If I Control C, Control Alt V. So then we have kind of one like this. Let's try maybe that one. Then we start to see that kind of inversion. Whoa. So that's at 19 eV. back down a little bit further. Okay, so that's an example of us just using the slit, sweeping low loss energy to do some contrast tuning in this semiconductor device. So that was me just using the live camera view and just manually changing the energy loss. So we have the presets, so we could jump to Plasmon, so that default is 25 and 5 EV. ZLP we've already seen. So live camera view. So we can actually do this capturing data using the EFTEM palette. So everything to do with EFTEM kind of capture, not mapping, is this top row here. If you look in the EFTEM palette, you've got 3 buttons. They have kind of small text in the top. So that says I kind of sub T. That means total. So that's the unfiltered. It's the whole spectrum. This I0 means we're getting the zero loss intensity. So that's a zero loss image. And then ESI is just a filtered image at some energy that we specify. So I'll go ahead and just show you how to use the features in this palette. So if I click on any of these buttons, what pops up is this dialog. So it's common to all of them. So we have some filter settings in this kind of top area and then detector settings in the lower area. So for unfiltered, we can't make any changes to the filter settings because it needs to be unfiltered. It needs to be 0. It needs to have no slit inserted. Auto exposure is generally a good start point. So we'll leave auto exposure and align some frames checked. And for an unfiltered image, we have a lot of signal, so I don't need to do any binning. So I'm going to leave it at unbin, so 1x binning. We can either hit done, or if we want to capture straight away, we can hit capture. So I'll go ahead and hit capture. And then my unfiltered captured image ends up in this multi-map workspace. So let's go back and do the same for zero loss. So zero loss, you can see now, again, it has to be at 0, so we can't make changes to the energy, but we can change the slit width. I'm going to leave it at default 10, and I'm going to go ahead and stick with binning 1 and auto and align some frames. I'd actually like to have that in the same workspace as the unfiltered image. So right click, move to workspace. Let's do that. Move to workspace, multi-map 1. Now multi-map 1 has our unfiltered and this elastic image. So when they're side by side, you can really see the difference. We have like much stronger contrast in the elastic image compared to the unfiltered image. Finally, let's have a little look at the ESI. So ESI, now we have the option to choose the energy and we have the option to choose the slit width. So one neat thing here is we can say use current filter settings. Doesn't really make sense in this case because I left it at 0 and 10 EV. So let's go back to the 19 EV looked quite interesting. So we'll do 19 EV and a 5 EV slit width. I think I'd like to do binning this time. So I'll do binning of 2. And I'm going to leave the auto exposure and the align some frames on as before. It's fairly standard to leave these 2 enabled. And I tend to, my personal choice is to choose the binning manually. So I would have 1x or 2x binning for stuff that's low loss, maybe 4x or 8x binning for core loss, like higher energy. So we hit capture and we end up with much the same. And then I will move this to the other workspace. Move to workspace multi-map 1. Let's get rid of that and that. And I'm going to call this EFTEM contrast enhancement. So there's our 3 capture images. So one thing that's important to kind of differentiate here with these capture options here in the EFTEM palette, if we compare, so we could do a capture with the camera palette. So this guy here, so you've got your capture there. So if you want to do something where the capture is going to be long, so maybe more than 1 second, it's quite useful to use the EFTEM palette, because the EFTEM palette here will capture in kind of chunks of 1 second exposures. And then we can make use of this, which we saw this. Let me see. So we've basically got our exposure. So I'm going to turn off the exposure, and then make it 10 seconds. So what this will actually do is there's a cap on the single frame time here of 1 second. So this would do 10 1-second exposures, and then we can make use of this align some frames. So it will automatically do a drift correction for us, which is pretty useful. So let's try that out as the last thing that we do and see how that goes. Yeah. So now, because I've upped the exposure time a bit, you can now see that we're doing multiple frame exposures, or kind of 1 second exposures, and that color figure that we just saw is like a cross correlation, so a drift correction measurement for that stack of images. Now let's move that one back to the contrast enhancement workspace, and there we're good. There we go. Okay, so that's pretty much all I want to show you in terms of the software for contrast enhancement, or the online software.